Hello. Today we are going to do Unit 7, Day 3 notes, solving for a side or angle of a right triangle. So there's certain steps we're going to have to follow. So as usual, once you notice you have a right triangle and you have an angle measure, you have a side, or you have two sides and you're looking for an angle measure, that's when we know we can use trigonometry. So you are going to actually first label what it is you're looking for with a variable. Like for example, this says find the length of AC to the nearest integer. So I'm going to put an X there. So we first want to identify what we're looking for. Then you're going to take your highlighter, and we have a reference angle 65, so I'm going to highlight both sides of the 65-degree angle. And then it says label your sides opposite, adjacent, and hypotenuse based off the reference angle. So opposite 65 is 13, and I'm looking for X, which is the adjacent. I am not looking for the hypotenuse, so I'm not even going to label it. Next it says choose a trig ratio. So let's go over here to our remember rocks. Remember our saying, so, ka, toa. Is the way we're going to help ourselves remember that the sine of theta, which is your angle, is your opposite side over your hypotenuse. The cosine of theta is adjacent over hypotenuse, and tangent is opposite over adjacent. So in this problem, we have opposite and adjacent. So the only trig function that has both is tangent. So that's the one we're going to choose. Tangent of theta is defined to be opposite over adjacent. So step 3, substitute the given numbers into the ratio. Well, theta is 65, opposite is 13, adjacent is X. So I'm going to turn this into a proportion by putting that over 1. And now I'm going to solve for the variable. I'm going to cross multiply. So I have X times tangent of 65 equals 13 times 1. Do you notice I put tangent of 65 in parentheses? It's important for our brains to know that 65 is our degree angle and it goes with the word tangent. So I put these in parentheses for 2 reasons. So one reason, they go together. The other reason is to show I'm multiplying. All right, now I have to solve for X. Now remember, this is just a digit. This is a number we're getting off the calculator. So I'm going to be dividing both sides by tangent of 65. So I have to divide both sides by tangent of 65. Those cancel out. So now I'm going to my calculator. The first time I'm using it, so I'm just going to double check. I'm pressing mode. I'm checking to see if I'm in degrees. I am. So I'm good to go. So now I'm just typing in 13 divided by tangent of 65. I'm hitting enter. This is step 5. Use your calculator. And now we have solved for X, and it said to the nearest integer. So I got 6.061 blah, blah, blah. To the nearest integer, we're going to look at that 0. The 0 tells us to leave it alone, so X equals 6. All right, let's try number 2. Find X to the nearest tenth. All right, so in this problem, it's labeled already what we're looking for. I notice it's a right triangle. I have a reference angle, so I'm going to highlight my reference angle. Now I'm only going to label the sides I need. So X is my opposite, and 247 is my hypotenuse. So now I got to pick a trig function. The only one that has O and H in it is sine. So I'm going to be picking sine of theta equals my opposite over the hypotenuse. So now I'm going to substitute in theta 73 degrees. Opposite is the variable X. Hypotenuse is 247. So again, I'm going to now solve. I'm going to cross multiply. 1 times X is X. And I have 247 times the value of sine of 73. This is already solved for X, so I'm ready to go to the calculator. So 247 times the sine of 73 degrees. So it looks like what I want it to say. Type this in. This said round to the nearest tenth. So I'm going to round right now. 236. I'm looking at the 2. I look one spot to the right. The 0 says leave that 2 alone. So rounded to the nearest tenth, we have 236.2. All right, number 3. Find x to the nearest degree. So x is now labeled in the problem. I'm going to highlight, this time I'm looking for that angle. So 14 is my adjacent and 67 is my hypotenuse. So the only one that has both adjacent and hypotenuse is cosine. So I'm going to pick cosine. So I know cosine of theta equals adjacent over hypotenuse. Now I'm going to substitute in x is my variable, adjacent is 14, hypotenuse is 67. All right, this is different. This is the first time where we're solving for the angle measure. And there is a different step you press on the calculator when you're solving for the angle. So if you look back up here, it says when solving for the angle, press the second button. This is something you need to remember to do. So let's highlight this. Anytime you are looking for an angle measure, the way you're going to type this in, the angle measure is going to equal, you're going to press second cosine, and then you're going to type in the value 14 over 67. So I'll show you what that looks like on the calculator. So do you see above sine, cosine, and tangent, there's sine minus 1, cosine minus 1, tangent minus 1. We're going to be pressing one of those. So this was cosine, so I want second cosine. And do you see it says cosine with like a little exponent of minus 1? That in math notation means the inverse. We're doing the inverse operation. Normally we know the angle measure and we ask for the cosine of that angle measure. But when we're looking for the number of degrees, we have to press the second button. So I typed in second cosine, and now I need 14 divided by 67. And when I hit enter, this is now the angle measurement. So it said round this to the nearest degree. Well, I'm making a decision about that 7. This 9 tells me to round that 7 up. So it's going to be 78 degrees. So anytime you're looking for the angle measurement, you're going to have two sides. You're going to press the second button. Okay? All right, let's flip this over to the back. We have a couple more problems. Find the value of the variables. If your answer is not an integer, round your answer to the nearest hundredth. Okay, so if you look at the picture, I see a right triangle, a 30-degree angle, so that's my reference angle. So I can go ahead and already highlight, according to the 30 degrees, I know the variable y is my opposite. 220 square roots of 3 is my hypotenuse. Remember, that's just a decimal. And then x is my adjacent. Well, I want my my pneumatic here to help me remember. So, ka, toa. All right, we need to solve for x and y. Well, you can't solve for both at the same time. So let's say we solve for x first. So x is adjacent, and we have the hypotenuse. So we're going to want to start with cosine. And I'm just going to substitute in as I'm going now. Cosine, I plug in my reference angle 30. I know is the adjacent, which is x, over the hypotenuse, 20 square roots of 3. All right, put this over 1, cross multiply. So x equals 20 square roots of 3 times cosine of 30. So it's already solved for x. I'm going to my calculator. 20 square roots of 3. Now be careful where your cursor is. So I have to go arrow to the right, and I'm multiplying that by cosine of 30. All right, double check. Looks good. And this is just the answer 30. So if your answer is not an integer, round to the nearest hundredth. So this is an integer, so we're just going to leave that as 30. Now, you could substitute this back in. We do know this adjacent side is 30, but that's not always the safest thing to do, because if you did the problem wrong, then you're going to be using this wrong answer to solve more math. So it's better to always go with what you have. We were given hypotenuse. We're now looking for the opposite. So now we need to do sine. So sine of 30 degrees is my opposite, which is y over the hypotenuse, 20 square roots of 3. Again, I'm going to solve. I'm going to turn it into a proportion, cross multiply. 1 times y is y. And then I have 20 square roots of 3 times sine of 30. All right, so again, just be careful typing that in. 20 square roots of 3. I have to move my cursor out. Times sine of 30. Double checking, see if it matches what I want. Looks good. All right, so this is not a whole number, so we need to round to the nearest hundredth, which is 2 decimal places. I'm making a decision about the 2. The 0 tells me to leave the 2 alone. So there you have both answers. All right, last one, a word problem, no picture. We're going to have to draw a picture. A slide 4.1 meters long makes an angle of 35 degrees with the ground. All right, so if I picture a slide in my head, I know there's like a ladder to get to the slide, and I don't know, let's say it's like one of those curvy slides. So it looks like this. I don't know, so here's like my picture of my slide. Something like this. You know, and here's my ladder to climb up it. That's pretty bad. But if you think about it, we have a right triangle. The slide is 4.1 meters long. That's my diagonal part. Makes an angle of 35 degrees with the ground. So they're talking about the slide, and I know the ground is here, so it makes sense that my 35 degrees goes right there. The slide with the ground makes an angle of 35 degrees. To the nearest tenth of a meter, how far above the ground is the top of the slide? Well, I know the top of the slide's here, so we're looking for pretty much like the height of the ladder you would climb up to get to it. Right triangle, I have a reference angle. I'm going to highlight. I'm going to label. X is my opposite side. 4.1 is my hypotenuse. Again, the only trig ratio that deals with opposite and hypotenuse is sine. So I'm going to start substituting in. Sine of 35 is my opposite over my hypotenuse. Put it over 1, cross multiply. Type it into your calculator. 4.1 times the sine of 35. Hit enter. It said round to the nearest tenth. So I'm making a decision about the 3. The 5 tells me to round it up. So it's going to be 2.4. And they gave us meters. So I'm going to label. And there you have it. It's pretty easy. Have fun and practice. Bye.